Alright, I'm back again. My name is Mntwana. Let's get started. So without further ado, let's get started. So we have some integral. This integral, they make a couple few students from one of the highest prestigious university, prestigious, the Ivy League university, say, hey, I gave up. I don't want to do math no more. Now let's see how we can handle this. You know, in a fast pace, and make sure that you understand each and every concept, because 99 or 90% of the students who do calculus, integration, they make mistake. They don't get this right. I don't know, for some reason it's confusing. Oh yes. Now I'm going to show you now how to handle this. Now let me start with this too. So whenever you have this type of, okay, you have a 1 and then you have a quadratic. You have a 1 and then you have a quadratic under the root, and then we come here. Which one should I start? Let me start with this one first. Number 3, solution. So if somebody give me this, you know what you do first? Make sure you test your quadratic. Only if there's a 1 on top. Test your quadratic. How? We know the root of quadratic. If it's greater than 0, then you know yes, you can factorize. But if it's less than 0, no, you cannot factorize. So now we're going to say, okay, wow, what is it? B 12. 12 squared is going to be 144 minus 4 times A equal to 1, and then times C equal to 85. So if this is going to be 144 minus, this is going to be very big a number, because times 2 190, times 2 380. So we know by any means this value is going to be negative number. So the negative number we know is less than 0. So if it's less than 0, then we know, oh, then the roots are imaginary. So if the roots are imaginary, you cannot factorize unless if you use a complex root factorization. And we don't want to go to complex root because we have another alternative that we can do. So for that case, I know, well, I'm not going to factorize. However, then if you cannot factorize, then at least do completing the square. So we're going to complete the square, that part. Now let me show you how you can complete the square. You know how to complete the square, so I can just go quick. So this is going to be, look, this is going to be x squared plus, okay, I can just go straight. Okay, x plus 6, because I take 12 divided by 2 equals 6, and then x plus 6, and then see, square, and then plus 85 minus square of 12. Oh, maybe I should just go slow. Maybe some students, they don't know how to minus 1 minus 30. 6 is going to be 49, and then x plus 6 plus square 49. And this is going to be x plus 6 square plus 7 square. That's a completing the square. You know, it's just in case if you don't know how to. But I do believe you do integral, then you know how to complete the square. If you don't know, then let me know. I can share the video that you can do complete the square. So this question is going to become 1, and it's going to be x plus 6 square. You see what I'm saying? And then plus, what, 7 square dx. So this one we know is tan inverse. So if it's tan inverse, we know in tan inverse, somebody give you integral of, let's say 1 over f of x square plus a square dx. We know this is same as, you say 1 of, only there's no root, and then you say this is tan inverse. Means you have a function square plus a square, there's no root. Then you say 1 over your a, and then you say add tan. When you say add tan and tan inverse, the same thing. Write your function here on top over your a, and then you plus your c. Why? Because there's no limit. So we're going to do the same thing here, because you got function plus a number square, and there is no root. So this is tan inverse. Now, so this is going to become 1 over, just like other formula say 1 over a. What is a? A is this number with no square. And then we say add tan. If you don't want to say add tan, you can simply say tan inverse of a function. What is a function? A function is x plus 6 with no square. And then divided by this number, which is here with no square. And then we plus c. Why we plus c? Because we don't have no constant. So this question is done. So the important thing is to make sure you test. Make sure you test your root of quadratic, because it will save you time. Now let's go for, since we did this, now we go for that one. So this one is done already. I can just leave it. I don't have to waste. Okay? Alright, beautiful family. Now we want to go for question 4. I'm not going to go in order because here I did this. Let me go and do that one. So that one, okay, let's just do this. Alright, dx is still dx. Okay, we don't want to waste things. Okay, now we go for that one. So if there is the same thing but there's a root, is different approach. So I'm going to show you the easy way how you can do it. So what you do, we're going to say this is equal to, I can write here, so this is going to be equal. So this is going to be 1, but we already did complete the square. This is x plus 6 square plus 7 square. And then you write your root. You write your root. So whenever you have a root, it's like this. Look, if you have a format of integral, integral, and then somebody give you 1, and they give you function square plus a square, and then you have a root dx. This same as say ln, and then you write your bracket 1 over a. We know a means this number here, and then write your absolute, and then write exactly what you have here, which is what is f of x square plus a square, and then what you do, you plus only function square, only function, not square, just only function. Then what you do, you close your absolute, and then you close this bracket, and then you plus your c. So we're going to do the same thing for this, because this is the same as format is there. You got your function plus a square, and then we have a root. You see? So now we're going to say, well, this is going to become, okay, so we say 1 over a. What is a? A equal to 7. It's going to be 1 over 7. And then we say we have a ln, and then we open the bracket, and then after we open the bracket, you say 1 over, oh, wait, I'm wrong. Ln face is not 1 over a. I was very wrong. I apologize. So we say, okay, ln, and then you have a bracket, 1 over a. So it's 1 over, what is that a? Our a means this number here, which is 7. 1 over 7, and then after that we say ln 1 over 7, and then we write our absolute, and then write our absolute, and then we say we write our absolute. This is absolute right here. It's not very clear, but it's absolute. Okay, we write our absolute, and after absolute we say, well, write exactly what you have here, which is this x plus 6 plus 7 square root, and this, remember, is that, so I can simply this is that. So I can simply write here, or I can write this, but I'd rather write that one. So I can say then absolute, write exactly x squared plus, because this is a function, this is that. But I want to write that, so 2x plus 85. And then we say we plus. What's your plus? You only plus your function. What is a function? A function is this x plus 6. Bracket x plus 6. Okay, and then what you do is close the bracket. And then you close the bracket, you say, well, x plus is x plus 6? Yeah, x plus 6. And then what you do, you absolute, make sure you close the absolute again, close the absolute. You see what I'm saying? So let's close with the red. And then after that, you plus your constant, and that's the end. You finish already. So we're going to do the same thing with the same approach with the second question. Let me check if the camera is recording, because sometimes it does, like, thinking it's recording, then it's not. It does. So the second question, we're going to do the same approach. So then this will be done. We'll go to the question number 2, and then after that we go to question number 1, and then we'll be done. We're out here. Okay, question number 2, the approach is almost similar. So we're going to take that one, and then we have to complete the square. But we say face, but there's not, okay. Here, we don't have to factorize anyway, because you know why? There's a root. So as factorize is not going to save our life, excuse me. It's not going to save our life because there's a root. So I'm going to do the same approach like how I did that number 4. So I'll say, well, this plus 12 plus that one, I can say same as, okay. I run my integral. 1 over square root. When you complete the square, that's going to be x plus 6 square, and this is going to be 7 minus 36. 7 minus 36 equal to 7 minus 36 minus 7, 29. Okay, 29, so it's going to be minus 29. You see what I'm saying? So that's what we have. So what we're going to do now, since we have that, we're going to use the same tactics. But look. Remember, according to the formula of the same tactics, the same formula that I show you, it say it must be integral, and it must be 1, and then we say f of x square plus a square root dx, then it's going to be equal to ln, in the bracket, 1 over a, and then you write your absolute, and then you write exactly f of x plus a square. So f of x plus a square, and then we have our root, and then after that we plus our f of x with no square, and it's out of the root, and then we plus the constant. So if you can look careful here, we say, well, it must be a square. So this one is not a square, because 29 does not have a root, because if it was like, say, 25, you can say it's equal to 5 square. If it's 9, you can say equal to 3 square. So if it's 25, means you can say 25, put root and then square. Because when you put root and square, means the same thing with 25. It's not going to make a difference. If somebody say, right, this is a square. What I'm going to do is say 3 square root and then square. So what I'm going to do, I'm going to say 29, and then I'm going to put the root. And after put root in the word dual, I will square. Remember here we have our dx. So then I'm going to use that formula and get it done. It's very easy, man. And very interesting at the same time. So this same is say, let me use a red pen a little bit. Okay, so this equal to 1 ln bracket 1 over a. What is a? Our a equal to square root of 29, because you take this one with no square. So square root of 29, yes. And then you say you write your absolute. Okay, let's use another pen for absolute. Okay, we write our absolute. And then what you do, write exactly. But this, remember, is same as that. Because remember, this one, it brought up to compared to the square. So rather write that one. So then I'm going to say, let's write our right again. Okay, so I'm going to say square root. And then this is going to be x squared plus 12x plus 7. And then we say we plus only our function. Okay? Only a function, because this x squared plus a squared means this one. This is the same as that. Or you can write this and then write again. In the next line, write that. But I'm trying to save a space. So I'm going to say a plus f of x, or the fx means this one, x plus 6. X plus 6. And then what we do, close your absolute and then plus c. And that's going to be the end of the question number 2. Now let's go to the question number 1 and see how we can handle question number 1, right? Okay, so now, so question number 1, remember you cannot use a formula. That one we must test, and either we use tan inverse. If it's not tan inverse, means we can use partial fraction. And we can use, if you don't use tan inverse or trigonometric inverse, because I can say only tan inverse, it can be any trig inverse, cosh, whatever. But if you cannot, then you use partial fraction after partial fraction, and then after partial fraction, then you go for the other one, you know? Okay, let me show you now how we handle that. Okay, so now that one, what I'm going to do, I'll separate again. So I'll say that same as say integral 1, and this is going to be x plus 6 we already did, and this is going to be negative what? 7 minus 36 equal to negative 29. So we say this is going to be square root, and then we're going to square dx. So what I'm going to do, I'm going to say, let me let this equal to a certain letter. So I'm saying, because you cannot use this tan inverse. You know why we cannot use tan inverse? Because there's no plus. If it was plus here, I was going to use tan inverse. But since it's minus, you cannot use tan inverse. You see what I'm saying? So I'm not going to go for trigonometric rule or trigonometric inverse or trig substitution. What I'll do, I'm going to let this, I'll let substitution u equal to x plus 6, du equal to dx. So I'm going to place that one, and everything must be in terms of u. So this is going to become integral. Okay, du equal to dx means this is going to be du over, okay, this equal to u, but what? Square, and this is going to be minus square root of 29. Square root of 29 bracket on square. So what we're going to do now, you see, now what we're going to do here, we're going to use partial fraction. You see, we're going, no, difference of 2 square facing is going to be partial fraction, because this time we say integral du, and then I can say bracket, because this is a different 2 square. The first one, because if somebody give you x square minus b square, this time we say x minus b, and then x plus b. So I'm going to use the same tactic here. I'll say, okay, this is going to be u minus square root of 29, u plus square root of 29 bracket, and the du. So then I'm going to say, excuse me, sorry. So then I'm going to say, okay, so we can use partial fraction. How do we use partial? Let me take this aside, this one here, and deal with it as a partial fraction. It's going to be 1 over that one. So I'm going to take 1 u minus square root of 29 bracket, and they say multiply by, bracket, and they say u plus square root of 29 bracket equal to a over the first one is a partial fraction, so we have over u minus 29 square root bracket, and then we plus b over the second one, b over u plus, this is a partial fraction, 29 bracket. You see what I'm saying? So what I'm going to do here, for me to get the value of a and b, so I can go there and plug there, so I can solve the integration by partial fraction. I got the video for the whole partial fraction. So what I'll do, I'm going to multiply by this throughout. Take this one here, multiply on here, means multiply by the same thing here, and then multiply this here, and then take this everything, multiply here. So look, if you multiply the same thing here on top, means this and this is going to cancel. Because the same thing you multiply here. They take this, multiply here, take this, multiply here. So if you take exactly this one, you plug in here, look, means the negative and the negative is going to finish because you assume this is there. So the negative and negative is going to finish. Means here it's going to be a times, what you're going to be left is going to be like this. Look, a times or times, because negative finish is going to be a times u plus 29, and then plus b. When you take this, plug in here, means the positive, and then positive is going to cancel, means it's going to be what's going to be u minus what? 29. Remember on the left, you multiply everything in here, means the same thing cancel, so we left with 1. So 1 equal to that one. Means 1 equal to that one. So what we're going to do, we're going to find the value of a and b. So now how am I going to get, for example, how am I going to get the value of a? To get the value of a means I'm going to assume u equal to square root of 29, so u can disappear. Look, if I assume this u equal to square root of 29, and then I plug in here, what happened? Means it's going to be square root of 29 minus square root of 29 is going to be equal to 0, 0 times b equal to 0. So everything here equal to 0. So here is going to be square root of 29. Square root of 29 plus square root of 29 is going to be 2 square root of 29 times a equal to 1. Divided by 2 square root of 29. Throughout means it's going to be 2 square root of 29. And this is going to be 2 square root of 29. So this and this cancel. So a equal to 1, 2 square root of 29. So I can say, well, I got my value of a. I can write aside a equal to 2 equal to 1 over 2 square root of 29. Okay, now how are we going to get the value of b? The value of b, we're going to use the same tactics. Means for me to get the b, I must eliminate a. For me to get the b, I must eliminate. How am I going to eliminate a? For me to eliminate a means this a must be, means this I have to let u equal to square root of 29. You know why? Because if I put negative square root of 29 plus positive square root of 29 is going to be equal to 0. If I put the u equal to negative square root of 29, it means you plug in here. Plus square root of 29 is going to be equal to 0. So 0 times a equal to 0. Okay, now here is going to be, because this u we say equal to that one, so it's going to be negative what? Negative square root of 29. Negative 29 minus negative square root of 29 is going to be 2 negative square root of 29 times a. Times this. Times b, my part, times this b. And here we know it's 0, everything's 0. So then how I'm going to get b? I'm going to divide, okay, it's like say 1 equal to negative 2 square root of 29 times b. I hope you understand, right? If you don't, please let me know. Okay, so what we're going to do now, we're going to divide by 2, negative 2 square root of 29, negative 2 square root of 29. This and this cancel. So b equal to, same thing but with the negative. So b equal to negative 1, 2 square root of 29. So we have a and b. So what we're going to do, we're going to plug in here. So let's see right here and make some space and get it done. Okay, so we have a value of a and b. So what we're going to do, we're going to remove this a, because the value of a we know. A is going to come in here and this b is going to come in there. You see what I'm saying? Means if I had to replace all of this stuff here, which is this, all of this, which is this, I'm going to replace with that. So it's going to be easy for me to integrate and put the norm. So I'll say, well, so this question here, which is this part here, is going to become that. So I say, well, this is equal to a. What is it? A equal to 1 over 2 square root of 29. Let me see if it does record. Sometimes it does not record. Oh yes, it does record. Okay. And then bracket this compared to the denominator, which is u minus square root of 29, the first one. And then we plus b. What is a b? B has a negative. So positive and negative is going to become negative. Negative. B, what is a b? 1 over 2, 29 in the bracket, u plus 29, but it has what? Has a root. Means this equal to that. You understand what I'm saying? So for that case now, I can say integral of this is like integral of this instead. Instead of write that, which is this, I'll write this because it's going to be easy for me to integrate. So integral of these two dx. You see what I'm saying? So I can erase a little bit. Oh, can you see? Okay, so I can separate this integral for the first group, integral for the second group. You know what I'm saying? So then if I do integral for the first group and second group, means I can simply say, okay, integral of the first group and the integral of the second group, dx separate. You see what I'm saying? dx. I hope you can see. So for that case now, I can take this out because constant, take this out because constant means then, but when you write an exam, show all the steps, right? Means this is going to come in here. And this is going to come in here because these are constant number. So it's going to go behind it. So this is the loan. This one is the loan, my beautiful family. This is a loan and that loan. The question is going to finish very soon. So then I can say, Okay, I can say, okay, I don't need this on here, right? I don't need this, so we can just make a little space here. We finish up now. Okay, so for that case now we're gonna say this equal to what? Equal to what? Okay, that's equal to, okay, so we have a 1 and then have a 2 square root of 29, and then when this is gonna be ln of this on here, which is gonna be absolute u minus square root of 29 minus 1 over 2 square root of 29 square root of 29, and then we say what? Ln of u plus square root of 29 absolute, and then we say do not forget to plus your c. But hey, we know the value of u. What the value of u? We did later remember the value of u equal to that one. So you have to replace the value of u equal to x plus 6. So I'm going to say, first and foremost, I can take this out if I want. I can say, well, I know this is constant, so I can say equal to 1 over 2 square root of 29, and then I can say all of this in one bracket, ln absolute, excuse me, u, what are u? X plus 6. So I can say this is going to be x plus 6 minus 29 absolute. Okay? And then we say we can put it like this because this is there, in it is a 110. Now you come here, you say, I don't want it because this one went out in the bracket. So this is going to be minus, minus. Let's do it like this. Absolute, absolute. And then we say here, ln absolute. We know the value of u. U equal to x plus 6, x plus 6. Okay? And then you close bracket, and we say plus square root of 29. And then what we do, close your absolute. And then we go. And then you close your absolute, and then you plus your c. But for the most case, they don't leave us that as the final answer. Let me show you how to leave us a final answer. Finally, what I do for the most case, because sometimes you may use your stuff, so why is not looking the same final answer? Okay, 1 over 2 square root of 29. We open. Look, I can divide here by square root of 29, and here I can divide by square root of 29. So this is going to become ln absolute x plus 6 square root of 29, and then I can say minus 1, stuff like that. For the most case, they write like this, and then minus, minus, and they say ln absolute. Now we come here, it's going to be x plus 6 because I divided by square root of 29, square root of 29 here only, over square root of 29, and this is going to be plus 1, close the absolute, plus c. You see what I'm saying? So meaning, if you take the whole question and start to solve it, this part here is going to give us a final answer. For that, be safe, man. This is Mntwana. Share this video. Leave a comments. Okay? That's why you see a lot of students get confusion with this because of that. It confused a lot of students because of that. Like, oh my God, I'm trying to do, but I can't get it right. I don't like math. Math is tough. It is easy. Easy. We're done. Peace. I'll see you soon. Subscribe. Hey, follow me my other Instagram page, my other social media page like Facebook, Mntwana _ Wabantu. In the Instagram, the same name which is written here, and also you can follow me on my Facebook, Mntwana Wabantu Academy. Just follow my Facebook page, and hey, don't forget to do donation to your boy, man. Only school convenience. Now like, oh, you must give now, you know, so we can continue doing this movement. Okay, thanks a lot for your time. Peace, and I'm gonna see you soon. I'm out.